and let's demonstrate that we can very quickly add some more operators which would be very similar to what we just did. For example, we could add another rational operator, and it's a binary plus operator, right? So very similar thing. It should no longer be constant, because actually no, why not? The plus creates brand new object, but the original objects remain to be constant. So let's try this. Manufacture brand new object which is the result of binary plus, right? So again, copy and paste into the implementation file. Okay, and in the implementation file, we'll just say, all right, so, wrong place to paste it in. Nested functions are not allowed, so this needs to be another rational operator function, which takes other, which will have a body right here, and what we're going to do is return brand new rational object constructed from, because this is a plus, so we need to find a common denominator, right? So we need to say, all right, I guess integer common denominator equals this denominator, right? This denominator multiply by other, right? Is that right? Other denominator, I guess. So we can multiply it, and then we can produce the rational, which when we construct it, we pass basically our numerator times common denominator. So I'm doing something crazy, but that's the quick solution, not optimized. I'm sorry, just run out of space here. So this plus other numerator multiplied by common denominator, comma common denominator. So this is not a reduced fraction, but it should work as an addition operator. So I construct rational object from those two pieces, right? This is my brand new numerator, and this is my brand new common denominator. And so we should be able to produce it, right? So this is an example of plus. Let's quickly see if this compiles. We'll say rational rat3 equals rat1 plus rat2. Okay, and that should compile.
Rat1 plus rat2?
Yes, thank you. Rat1. It should also work with rat2 plus rat2, but sure, yeah, why not? Take different objects. So build. So it missing something somewhere. Oh, I forgot the semicolon, I guess. Right? It's a statement. The return statement needs a semicolon. Okay, so that compiles. But to make things more useful, maybe we also need to add to our class. We need to add this. Essentially the output. The output will be returning this. It will not be what's the name of I think iStream is the type of standard library IO stream. So iStream, it cannot be constant because we're modifying the string. So this should be the parameter here. Stream. Okay, but the problem is that if I want, so this is my next challenge. I'm just trying to make sure that I can do this. Cout display rat3. Okay, I want to be able to display rat3 as I can display strings and integers and everything else. So I need to overload this operator. So one part of this operator is cout, and the type of cout is iStream. I'm sorry, output stream, ostream, right? Output stream. Okay, but to be able to do something like this, I need to specify the operator which takes cout and ret3 as other, So which means this. I cannot overload this operator as member function operator. I have to overload it as non-member. Control X, Control V, define it outside. So this particular operator is a binary operator which takes output stream as one parameter and which also takes rational. I'm afraid I'm going to be running out of space on this. Let me just temporarily collapse those multiple tabs. All right. So here's my my take on this operator, stream output operator. Right. So it doesn't use const anymore because we're now outside of the rational class entirely, and we say a rational const a reference to rat, right? Another rat. And that should be our function. However, because most likely these guys are private, we need to make sure that we declare this as a friend. Okay? This should be our friend function. Now, this file, of course, has no idea what this is, so therefore we need to include IO stream. Okay, so that everybody knows what that is, and I don't know, I'll just use std so that I don't have to use this using a declaration. And what is it not happy about this here? I don't know. Too many parameters for this operator function. Oh, well, I need to say that it's a friend, so it doesn't take it as a member function. So when I say it's a friend, it's not going to treat this as an overloaded operator inside of our class. It will understand that this guy is defined elsewhere, right? And so we declare it as an operator for everyone to use, but separately declare it as a friend inside of our class. It's unfortunately things begin to pile up quickly, but if you think about it, it makes sense. We need this guy to be our friend because otherwise it won't be able to access this and this, right? Because its compiler isn't going to allow it unless we make it a friend. This is standard procedure with overloading operators. So again, this needs to be saying std output stream, and I'm going to say Control C and bring it over to my implementation file. So this time, operator this is defined as not a member function, but simply as non-member function, freestanding function, which takes the stream and the rational and something like this between them. And therefore I can define it now as simply saying this: std cout display. What I could do, like use like little parentheses, and just also go vertical on this output. Then display rat numerator, right? This guy, and then display something like this, like the fractional line, and then display rat denominator, sure thing, and then display closing parentheses. I could probably just use like single character literals instead of C strings. I don't know if that makes much difference. It should be just maybe a little bit more efficient. And so I made my output, but then recall that to allow something like this, cout, rat 1, rat 2, and then rat 3, to make sure that it works, we need to return this. Let's talk about it.